We collect samples of data to study populations and infer things about the nature of them, as it is not often possible to collect data from an entire population. For example, imagine trying to determine the average height of men in England and having to measure every man in the country. This means we must look at parameters that describe the population by stating hypotheses that capture our thoughts about these parameters and what their values might be. We use a hypothesis test to confirm whether or not our beliefs about these parameters are true, and we do this for the population as a whole using the data sample we have collected. Examples of hypothesis tests you might come across in your studies: binomial tests for a proportion, where we test if a population can be modelled by a binomial distribution with parameters n and p. The test determines if p is equal to some hypothesized value. Z-test with the mean of a normal distribution, where we test if the mean of a population assumed to be normally distributed is equal to some hypothesized value. The test for zero correlation, where we want to test whether or not there is significant correlation between two variables. You'll also come across the following key terms: null hypothesis, often denoted H0, the hypothesis that you assume is correct until you have evidence to suggest otherwise. This is usually that there is no significant difference or no effect. Alternative hypothesis, the hypothesis we suspect is true if the null hypothesis is not. If there is significant evidence against the null hypothesis, then we will reject that in favour of the alternative. This is usually that there is a difference or some effect, and it's denoted H1. One-tailed or one-sided test. A one-tailed test looks at whether the specified parameter is either bigger or smaller than some hypothesized value. If the parameter value is suspected to be less than the hypothesized value, we say it is a lower-tailed test. If the parameter value is suspected to be bigger than the hypothesized value, then we say it is an upper-tailed test. Two-tailed or two-sided test. A two-tailed test looks at whether the specified parameter is different from some hypothesized value. It looks at both tails to check which way the difference in the parameter value might be. Test statistic. This is a quantity with a known distribution that we calculate to determine if we have enough evidence against the null hypothesis. This will depend on the type of hypothesis test you're carrying out. Critical value. A value from a statistical distribution which is the least extreme value of the test statistic for which we would reject the null hypothesis. These values are usually found in statistical tables. Significance level. This is a threshold we use to determine whether we reject the null hypothesis. If the p-value is less than the significance level, usually denoted alpha, then we reject the null hypothesis. Most commonly, the significance level is set at 5% or 0.05. P-value. The probability of getting a value of the test statistic as extreme as we have, given that the null hypothesis is true. The smaller the p-value, the more likely we are to reject the null hypothesis, as the probability of it being true gets smaller. The key steps that you might use when you are conducting a hypothesis test can be thought of as the following. Number 1, determine the null and alternative hypotheses. Number 2, calculate the test statistic. Number 3, decide whether to reject or not to reject the null hypothesis at the significance level. And number 4, make conclusions and interpret them practically in the context of the question. Let's take a closer look at these steps. The null and alternative hypotheses can be thought of as opposites to one another. One of them we accept, the other we don't. They're often contradictory statements, one of which suspects an effect, the other that there is no difference or change. An example set of hypotheses is shown here. If we were testing whether the value of a parameter mu was equal to 10 or less than 10, we would use the null hypothesis H0 mu equals 10 and the alternative H1 mu is less than 10. For a one-sided lower-tailed test, we look at the parameter value being less than the hypothesized value. For upper-tailed tests, the parameter value is suspected to be higher than the hypothesized value. And for two-sided tests, we suspect the parameter value is different from the hypothesized value in either direction. Step 2 is dependent on the test you are carrying out. The statistic you calculate will be based on a random variable with a known distribution. Find the formula for the test statistic that is relevant to the test you are doing and calculate its value using the sample data you have. For example, in a test with a mean of a normal distribution, we would use the Z statistic as shown here. Step 3 can be done in 3 different ways. Option 1, find a p-value and compare it with the significance level of the test. This is done by directly calculating the probability of getting your calculated value of the test statistic given that the null hypothesis is true. Then we reject the null hypothesis at the significance level if p is less than or equal to alpha. Don't forget that you should use alpha divided by 2 for a two-sided test. The second way to carry out step 3 is to compare the calculated value of the test statistic to critical values in statistical tables. You will find statistical tables for each distribution which lay out critical values for each set of parameters and significance levels. You need to use the table relevant to the distribution of the test statistic that you are using. The way to decide whether or not we reject the null hypothesis here depends on what the alternative hypothesis is. For a lower tail test, we reject the null hypothesis if the test statistic is less than or equal to the critical value at the lower tail of the distribution. For an upper tail test, we reject the null hypothesis if the test statistic is greater than or equal to the critical value at the upper tail of the distribution. Finally, for a two-sided test, we reject the null hypothesis if the test statistic is less than or equal to the critical value at half the significance level at the lower tail of the distribution, or greater than or equal to the critical value at half the significance level at the upper tail of the distribution. The third way to carry out step 3 is to find a rejection region, the region in which we would reject the null hypothesis if the test statistic fell within it. This can be found by considering which values of the test statistic give a p-value equal to the significance level. Once we have found this critical value of the test statistic, we decide the rejection region based on the type of test we are conducting. For a lower tail test, this would be any potential value of the test statistic less than this critical value. For an upper tail test, this would be any potential value of the test statistic greater than this critical value. And for a two-sided test, there will be 2 rejection regions, respectively at potential values of the test statistic less than the critical value at the lower tail and greater than the critical value at the upper tail. The fourth and final step in conducting a hypothesis test is to make conclusions and interpret them practically in the context of the question. Depending on the outcome of step 3, you should now interpret what your conclusion means in the context of the question. If you reject the null hypothesis, then you have identified a significant difference, and so you can state what this means practically in the context of the question. If you don't find enough evidence to reject the null hypothesis, then you state this, along with what no effect or no difference means in the context of the question.